Alright, this topic's on factoring the difference of two squares. So, to show you how this works, we're going to actually work backwards. Alright, so instead of factoring, I'm going to start with the factored form and multiply this out so you guys can recognize the pattern that occurs here. So if I FOIL this out, or use the grid method, whichever way I can multiply two binomials, I do x times x is x squared, x times negative 4 is minus 4x, 4 times x is a positive 4x. 4 times negative 4 is a minus 16. Alright, and then when I simplify this, I have negative 4x and a 4x. Those are like terms. They're equal and opposite. So those cancel each other out. Right? Negative 4x and a 4x cancel each other out. It leaves me with just an x squared minus 16. Alright, let's try this again because I want you guys to notice the pattern here. Now keep in mind this is the opposite of factoring, but it'll make sense when we go to factor why this is what we're doing. So if I multiply, it gives me 2x times 2x is 4x squared. 2x times negative y is minus 2xy. Y times 2x is plus 2 times x times y is 2xy. And then y times minus y is a minus y squared. So now I look and I combine any like terms and we get negative 2xy, positive 2xy, those cancel. Gives me a 4x squared minus y squared. So what happened to our middle terms? Notice that each time our middle terms canceled because they were equal and opposite. So here the 4x and the negative 4x canceled. Here the negative 2xy and the 2xy canceled. Alright, and we ended up with the difference. Difference meaning subtraction. So the difference of two squares. Remember, a perfect square is just anything that can be it's the square of something, or you can take the square root of it evenly. So like x squared is a perfect square. 16 is a perfect square. Alright, so see how they canceled out. Now when we're factoring, we want to look at anything that has two terms. We either look for a GCF, or, well, we always look for a GCF first, but then we look and see, are they both perfect squares? If they're both perfect squares, that means we can factor them. So look at the pattern, what happens. When I multiplied this out, it gave me a x squared minus 16. X squared is a perfect square, 16 is a perfect square. So when I'm factoring, that's when you start with x squared minus 16 and you end up with x plus 4, x minus 4. Alright, so how do we get from here to here? Well, we know that the difference of two squares, or we'll have these middle terms cancel out. So what we do is we look at the square root of x, that's just x. What's the square root of 16? That's 4. So we know that if we have two perfect squares being subtracted, we can take the square root of the first, right? What's the square root of 4x squared? That equals 2x, and that's our first term here. What's the square root of the second? Or the square root of y squared? That's just y. And that gives us a y and a negative y. So anytime we have the difference of two squares, a or b, or just any generic two squares, we can write that as the square root of the first, right? The square root of a squared is just a. That's where we get this. And times, so the square root of the first minus the square root of the second, and the square root of the first plus the square root of the second. Actually, it doesn't matter whether it's minus plus or plus minus. That's the commutative property. It works either way. So it's the square root of the first, and that's this first term, and then it's the square root of the second, which is this second term. Alright, so look at, we have two terms here. Are they perfect squares? Well, we look and we see that yes, n squared is a perfect square. What's the square root of n squared? It's just n. So we're going to have n as our first term. 64, what's the square root of 64? That's 8. So it's going to be a plus 8 and a minus 8. That's it. If you multiply it back out to check, you'll find that you get this exactly. So let's do this one real quick. Multiply it back out, we get an n squared. N times negative 8 is minus 8n. 8 times a positive n is a plus 8n. 8 times negative 8 is negative 64. These are equal and opposite. They cancel. We have n squared minus 64, which is what we started with. So it does work. Remember, factoring, this is our final answer. So here, we have two perfect squares. What's the square root of 4m squared? That's just 2m, right? Because that's 2m times 2m. That doesn't look right. So what's the square root? Oh, what's 4m? That's the same as 2m times 2m, right? So the square root of 4m squared is 2m. What's the negative 81 squared? 81n squared. That's 9n times 9n. So the square root of 81n squared is 9n. And just make sure that you have one sign negative, one sign positive. Now the only thing that we might need to do is to factor out a GCF. You always look for a GCF first anytime you're factoring anything. So with this one, I can factor out a 2. What else factors out? I can also factor an a out of both. And that leaves me with an a squared and minus 49b squared. Sorry about that. Alright, and those are two perfect squares. So I can't forget the 2a, I got to keep it here. But I'm going to just factor, I'm only looking at the blue here. So I'm going to have an a and an a, because that's the square root of the first, and a 7b and a 7b, because that's the square root of the second part. And that's going to be a plus and a minus. That's all done. We factored it completely. Alright, now you try. Look for a GCF first whenever you can, and then find the square root of the first, that's your first term, square root of the second, that's your second terms, and then it's a plus and a minus, or a minus plus, either way.